Welcome to this next video, and yet again we're going to be looking at the PCA9685 PWM servo driver board, and this time we're going to be controlling servos with buttons, basically making them move clockwise and anti-clockwise using the buttons. We're also going to be adding a couple of relays in. This is because although this code is useful if you just want to control servos with buttons, this is part of a bigger project to do with model railways. And for those of you who are into your model railways, sometimes when you want to control the turnouts or points, depending where you live, sometimes you need to switch the power on the frog of the point. This is especially common with DCC, and so in this project I'm going to do an experiment with relays to switch that polarity over. Now I use this on my own layout, so I know the theory works, but I use mine as DCC decoders. We'll get to that in a couple of episodes time, but for today we're just going to look at three different samples of code and also look at some of the issues that can come about when you're using these servos and relays to control your layout. So our PCA9685 board hasn't changed in looks, but that's what we're using. This is the third in a series, so I will be using some code from the previous tutorials, so I'm not going to explain certain bits in detail. You'll have to nip back and see the other tutorial. So I'm using this for model railway control for the points or turnouts. So in this one, as well as setting the angle of the point so we can swap one direction to another, I'm also going to be changing the polarity of the frog, and this is done using these relays. Now these relays are a particular type. Sometimes you'll get them with two connections. The ones you want for this job have the three connections, and that's because when these relays are powered it makes a circuit, but also when the relay is not powered it makes the opposite circuit. So that means that when we switch it on we can add one polarity to the frog. When we switch it off we can add the opposite polarity. Hope that makes sense. It all works because I use it on my layout. Right, what type of board should we use for this project? Now I'm going to talk a little bit more about projects today because you need to start thinking about what's going on as you build a project. So if we go back to our board, we've got 16 servos that we could add to this. Now with 16 servos, if we're going to use two buttons for each servo, all of a sudden we've got 32 buttons. Now if you're going to use a pin for each button, that means you need a board with 32 pins, so you're already looking at a mega. And if you're going to start to use relays for point control, you now need 16 relays. That's another 16 pins. Now there are ways to reduce the number of pins. We could look at sort of resistance ladders, and there are some ways of adding extra pins to any board. But the reason I've just brought that up is it's very easy to get carried away with something and, if you like, order the board before you've thought what you're doing. So with a project like this you need to start thinking, just how many pins do I need? Now going forwards, when we get to the sort of digital control system, of course all of a sudden you need very few pins. So again, it's worth thinking through the different stages, what you're doing. Now another issue that came up as I was working on this, and this was bizarrely because a friend of mine had mentioned to me about his club were building a layout with 300 hand-built points or turnouts. And I was starting to think about this and using servos, and we were discussing this sort of thing, and all of a sudden I started to think, how much power do you need to do that? Now a lot of the time when we're building these projects, we don't think about power, but we do need to think about power. So each servo, and I'm using these little MG90s or SG90s if you're using the plastic geared ones, they draw 70 milliamps all the time, even when they're not moving. That's just to keep the circuitry going. Now 70 milliamps, we're not going to lose any sleep over that. But there is a thing called the stall current. Now this is the amount of power that the servo will use at its maximum point. And the way to think about this is, if the servo's trying to move and you're trying to stop it from moving, it will use more and more power to try and get its way. And that's when you start to get up to this, you know, the stall current. It's the amount of current it's using when it just can't move anymore. So it's maximum power. Now that's 500 milliamps. 500 milliamps is half an amp. Now imagine my friend, and he's got 300 points. All of a sudden you start to think, whoa, if you move them all simultaneously, you would be using a huge amount of power. And that's just something to think about. I mean, 300 times 70, you're starting to use a lot of power. So this is just something to think about. The other bit, when it came to the relays, these relays are supposed to be drawing 560 milliamps when they are activated. Now this becomes even more of an issue, because with the servos we can do some little trickery in the code so that we don't move all the servos simultaneously. We can move them in a sort of a flow, so they'll move pretty quick together but not all at the same time. You can move them at the same time, just be aware you're going to need the power to drive them. But the issue that we've got with this system, if I'm using a relay plus a servo, even if I've got my system set up, you know, because let's be honest, my servos are not pushing 500 milliamps because the mechanism is quite smooth, but I bet I can get up to 300 milliamps plus 560 milliamps. So that means I could be moving, you know, 0.86 of an amp every time I'm moving a servo. And for some of those servos, if they move in a certain direction, even when this turns off, so drops down to 70, if the circuitry requires the relay to be triggered, then it's going to be drawing 560 milliamps. If I've got 16 servos on this board, you start to see that we're starting to use a lot of amps. So these are things to think about. And although this code, the last example, has these relays in, I'm going to be honest with you, and you know, I use them on my layout because I've only got a few points, but for a bigger layout it's not the answer. And in a later series I will address how we need to do this without using these relays, because we got to get away from them. Okay, let's get on with the project that we're doing. Now there is a warning here: don't connect the 5 volts to your Arduino. If you try to draw the power for the PCA board from your 5 volts, your Arduino is going to have a very bad day. If you don't burn it out, it's going to grind to a halt anyway. You know, it'll just run out of power. Even if you were to connect 16 servos on here, your USB supply off your computer or whatever is not going to give it enough oomph. As we've seen, as we're doing these power calculations, suddenly you realize you may be using a lot of power. Now, just like in the servo setter, we've got 4 buttons that I'm using because I'm only doing 2 servos. The code's been written in such a way that it's expandable. Each of the buttons has got a 4.7k pull down resistor, and then in the extra one on this project is I've got the 2 relays added in on pins 12 and 13. So all the wiring diagram is in here. Now if this is your first attempt at using one of these PCA9685 boards, do the connection test. Just make sure that you've got a connection to the board, and also make sure that you've got the Adafruit PWM servo driver library installed. Again, all on the Digital Town website on how to do it. Right, let's get on with our first example. So the first example, we're just going to be moving the servos with the buttons. There's no relay code in this one. Pinouts are in there. There's also the diagram on the Digital Town website. I'm not going to go through all this in detail because we've been through it on the servo setter and the previous tutorial I did. So if you need to understand what's going on here, I suggest you go and have a look at those tutorials. All of this coming right down here, adjust some settings for the servo driver board. You don't need to mess around with it if you're just doing it as standard. And again, in the setup, this code as well, you don't need to touch it, just leave it alone. That's just dealing with the setup of the board. Now, we've then got below this 4 pins that are being set up. These are the 4 buttons. So servo 0 left, servo 0 right, servo 12 left, servo 12 right. That's because when I plugged my servos in, I decided to plug them in to 0 and to 12 on the PCA9685 board. So I thought it would be sensible to make the variables relate to the port that I was going to plug them in on, especially if you wanted to expand this code for more items. Now the next bit down here, I've got some variables, servo 0 L pos and servo 0 R pos. These are the values that you would have got from the servo setter if you're working on a model railway. They're basically the angle that I want the servo to move to between 0 and 180. These aren't actually the figures that I got for the model railway. The reason I've picked these ones is I've done a little video of it working later, and of course for the model railway it doesn't move that far, so these just move it a more extreme distance. Then we've got current millis, which I always have at the start of the main loop, and then we've also got a button timer and a value here that's going to debounce the button. Now with the code, as usual, there will be no delays in the code. So this is written as state machine code, because if we had delays within the code, when you press the button, if the servo is doing something and it's using delay, you're not going to pick up the press of the button. So the code starts, we set the pin modes for inputs for the 4 buttons, and then in the main loop we've got current millis and button state as a function. So let's take a look at button state. Now button state is very similar to the code that I wrote for the servo setter. So it starts off first of all checking if it's time to even check if the buttons are being pressed. This is to do with debouncing the buttons, because if you pressed a button and didn't debounce it, in the speed that you could press it as fast as you could, the board would have read that as probably 300 or 400 presses. So this is a way of setting it, and the timer that I used was 200 milliseconds, so that's 0.2 of a second. So every 0.2 of a second it's checking what's happening. Now I've written this code similar to the previous example when we were doing the servo setter. Now the servo setter was only ever designed to have 4 buttons. It was a bit of quick and dirty code, and I've used this same code here. Now this works, but in the next example you'll see why this is not a good way to write the code. So what happens within this code is we have an if statement. So if the servo left button is greater than 0, so it's being pressed, it's got a value of 1, because again, we're only, if a button is pressed, we're then not allowing any input from any other button for 0.2 of a second, because that could really mess some stuff up here. So we're checking if the first button has been pressed, which happens to be the servo left. If it is, we pass our servo, this is our servo, and this is the position we want it to move to, and we're passing it to that function set servo position, which is that function I wrote a couple of tutorials ago that takes all the nastiness out of using this PWM, the Adafruit PWM library, and basically allows you just to pass the angle just as you would with the traditional servo library for the Arduino. Now what it then does is, if that's not been pressed, then the alternative is, has the servo right button been pressed? If those two buttons then haven't been pressed, do another if, and so it goes. Now this code works fine, it's absolutely fine. You press the buttons, everything moves. The problem with this code is it's controlling 2 servos with 4 buttons, and we're using a lot of if-else statements. Now can you imagine, if we've got 16 servos, that means we've got 32 buttons. If you can imagine, this code would become unmanageable. So although this works, and if you've only got 4 buttons, go ahead, and it's using the if statement, because a lot of beginners like to use the if statement, and I haven't had to use anything fancy in here that might sort of throw you a bit. But the reason I wouldn't normally write the code like this is it just becomes overcomplicated the more buttons you add. Because if you can imagine, you're going to have ifs within ifs within ifs within ifs, and if you make an error, you're going to sit there scratching your head thinking, where on earth have I basically missed the bracket? So let's look now at the second bit of code. So in this second example, we're going to get into a little bit more complicated code, but code that is actually far easier to work with, especially as you expand this. So this top section, all this stuff, exactly the same, no changes there. And again, in the setup, exactly the same to begin with. Now let's get back up here. So now let's get into our variables. Now I've set a definition of num buttons 4. This is different to defining to setting a variable. What this means is wherever this is written, the system will automatically replace it with 4. Now we've got 4 buttons, so we now have an array. Now I've done a tutorial on arrays. Some people get scared stiff of arrays. They're not as frightening as you think. Imagine a spreadsheet. The number of buttons is, if you like, the number of rows, and the 3 is the number of columns. So if you like, so A1, you would get this value, A2, A3, B1, B2. That's basically how it works. So what we're doing here is, if you remember in the previous version, if we just scroll up to the pin values, try and see them both at the same time. Yeah, got that about right. Right, so here we have the 4 pins that we're using, and this time we're putting them as the first item in the array. Now the next item in the array, do you remember we've got our servos 0 and 12? So what I'm saying is the first item in the array is this button moves this servo to this position. This button moves this servo to this position, this button moves this servo to this position, and so on. The reason for doing this, of course, is if you change this to 32, all you've got to now do is add in all the extra lines for your buttons and servos and the positions you want them to go to, and you'll see why this works so well later on. Now, when we go down to the setup, if you remember in this version, when we did the setup, we set the pin mode for the 4 different buttons. This time what we're doing is we have a for loop, and it's going from 0 to 1 less than num buttons, and because we start to count at 0, that means we will get to 4 items. It's then going to go through the array, and it's setting the first variable of the array. So if, like, from our spreadsheet, we're looking at is it row 0, row 1, row 2, row 3, and the first item, and that was our pin number. So we're passing the pin number to pin mode in a different way, but as you can see, it would mean that if you had 32 buttons set up in here, this little for loop doesn't change because num buttons will have changed, so it would just go through all your buttons in one go without you writing any extra code. Fantastic stuff, and that's what we're after here. Now, when we get to the button state code, so if you remember before, we've got our dreaded nested ifs that are going to go on for forever. This time we don't. So the first thing we do, as always, we're checking, is it time to check the buttons again? Has the debounce period gone by? And then what we're doing is we've got another for loop, exactly the same as you saw in the setup, except this time we're reading the again, we're reading that pin. Is that greater than 0? So if it's greater than 0, it'll be 1, the button's being pressed, and if it is, then we're going to set the servo. So now we're looking at, if you like, if that was row 1 pin number, this is row 1 servo number, and row 1 angle. So that's working through those 3 items. So what it's basically doing is sending the information to set our servo. It's saying which servo we want set, which position we want it set to. Now this next little line is a little bit of an odd one. This is going round in a loop. Now I don't want it to read more than 1 button at a time. One of the reasons for this is I'm allowing 0.2 of a second not only for the button debounce, but it also means you can't move a servo to more than 1 servo at exactly the same time. Now you may want to in your code, and you could take this out and you could maybe have 1 button that you press that would send 3 sets of values through. That's your choice, but from this project, to keep the power consumption down, once a servo has been pressed, it'll be 0.2 of a second before another button gets read. So to jump out of the loop, this is doing a counter up to num buttons. What it does is it immediately sets the value Q to the value of num buttons, which means the loop will end, we'll escape the loop and go round and round in circles. So it'll just then wait for the next button press in 0.2 of a second's time. What this now means is if you add more lines in here, more servos, this code stays exactly the same. And this is why, although using an array people don't like them, you start to realize if you can learn to use these things, then all of a sudden you can make your code far, far simpler to understand. And the less lines of code that you've got written, the less chances you have of a bug. So that is the second example. Right, so now for our final example. Now, for those of you who just want to use servos with buttons, you don't need to really worry about this next one. This is just another example where I take the previous code and I add in the relays. Now the relays are on pins 12 and 13, and again I've followed the example 2. The difference is I've now expanded the array. So the array we had before had these 3 items in. What I've now done is added 2 extra items, and it's now got a value for the relay pin and a value that I want the relay set to, depending which way the servo has been turned. So 12, turn it off, 12, turn it on, 13, turn it off, 13, turn it on. Fantastic. So again, little expansion of the array is all that was required. One of the other differences is in the setup. It's now working through the whole array, and it's now not just setting the pins for the buttons, it's also setting the outputs for the 2 relay pins. Now this is going round 4 times and there's only 2 relays. It actually sets them twice, but it doesn't make any difference. It's not going to affect the way the board works. It's not going to crash or cause you any problems. So it's just a very simple way of dealing with that in code. And especially if you were going to use a layout and you've got 8 relays, it just shows, again, you can just alter this area and everything else is sorted out for you. Now the only other bit of code that changes in this is in button state. So in the button state code, just as it did before, it sends the value to the set servo. So nothing has changed there. The only thing that's changed is this line that deals with the relays. So what it does is it then, as we've seen, that is the servo number and the position. The next item in the array, item 3, is the pin number for the relay, and item 4 in the array is, do I want that relay set on or off? That's what it passes over. So that's how this last example works. Again, very, very basic once you get used to the array code. So let's take a look at the final thing working. So this is my little prototype. As you can see, if I press the buttons, the servo moves, and if you look at the relay bottom left, you'll see the light coming on and off. You might even hear the click. If we go now to the other set of buttons, I haven't got a servo attached, but if you look at the board, you'll see the LED, because it's on pin 13, it's flashing. So the whole thing is working okay. The issues I have from a model railway point of view is the power draw from these servos. So that's something I need to look into. Now actually on that video I mentioned the power draw from the servos. It's not the power draw from the servos that are turning out to be the problem. It's the power draw from the relays, because obviously the relays stay on the whole time, whereas the servos do not. Now this is the little solution that I'm just working on, and I'll hopefully do something on this later. So normally I would just have this rod that's driving the point. I'm doing some experiments with putting this little piece of wire round the back. Let me just drag this other picture in. So this is it in place. So we can see the servo is driving the point as it was before. Now I've got these 2 bits sticking out the side. What I'm trying to work on is whether I can then make this so that when the servo turns to set the point, I can put a wire soldered onto here that will now make this replace the relay. Now if I can do that, I'm on an absolute winner, and I think it's more than possible. I've just got to get the setup right here. It's just not quite right yet, but once I get that done, I'll do a video, because if I can do that, that means I can do away with all the relays, which is not just a power saving, but if you've got a big layout, it also saves you quite a bit of money as well. So I hope that's been useful to you. And again, as I said, the code can be used for a lot of other things, anything you want to control servos with a button. So I hope that's useful, and if it is, please click the like and subscribe, and I'll get the next videos in this series out as soon as possible.